Classical Physics Tutoring, Chapter 7, Section 2, Curved Space and the Future of Physics. So this is the last video for the college levels classical physics. From here, we made many practice problem. Please check those videos. This solving the problem is a good way to understand the theory. So this last section is about the overall picture of the physics right now, the scale effect of relativity. So suppose you have a size, right, very tiny to all the way large, extend on both sides, and the humans is around here. And if you put the log scale, tiny is really tiny, large is like universe. Okay, now the Galileo's time, the telescope can see the planet and start observing Kepler's and Copernicus. So those data is available for Newton, and physics started with the scale of the human size. Okay, now put another axis, very fast. The speed was the human speed. So this is the area the Newton started with, and most of the human size and the human speed, this extremely fast, is almost light speed. Okay, the certain speed, up to certain speed, the physics works for the human. So there is the scale limitation. The classical physics is basically human scale physics. Means it's not too small like atom, or not too big like cosmology, and the speed is not too fast like light. So that's a scale limitation. But the good news is this human scale is best for engineering. Okay, so the architecture design to electrical engineering, mechanical engineering, all the engineering is all done. The one engineering nowadays, bios and chemistry, goes to this area. Okay, mainly because we have more equipment to observe the behavior of the smaller particles, and the quantum mechanics is extremely small and could be very fast too. And what happened is the relativity theory extends to very fast area. Okay, and very large size. So we have better telescope to observe, like a Hubble telescope, and the larger telescope to observe the faraway galaxy. And also we have equipment to measure the speed of the light. So this is the expansion of physics to the extreme area, right? And we can add one more axis, like 10 temperature, extreme high temperature to extremely low temperature. The extreme low, we are talking about superconductivity. Extremely high is a plasma physics, which we don't have really good understanding on the plasmas. Okay, so the science is expansion of extreme case, extreme speed, extreme size, and extreme temperature. Okay, so whenever we develop the new better equipment and we can observe, then we can verify, see if it's follow the physics law. If it doesn't, then we revise the theory. So its progress of the science is the observation method and the verification and the creation of theory, then observation and verification and the creation of theory. So it's goes spiral like that. Okay, so now we are talking about, is there anything beyond the light speed? And we are finding something. So the whole theory has to be revised. And chemistry handle the behavior of the electrons, but beyond the electrons, nuclear physics, that goes into the quantum mechanics. And we have a little bit more better understanding on the universe and the cosmos, but it's not quite there yet, because now suddenly we are finding a dark matter and dark energies. So the scale effect is the progress of the physics. And what's happened is, whenever the new theory is created and observe the things, the stuff you couldn't explain before is become possible to explain using a new theory. The good example is orbit of Mercury. Orbit of Mercury, very close to the Sun. The orbit has precession, and this Mercury's precession was not exactly the way Newton calculated. They couldn't understand why. And after the general theory of relativity come up, then it's predicted that there's a precession and exactly the way Mercury is doing around the Sun. So this is a good example of making a new theory and observe again and explaining. And if it doesn't explain, we have to create a new theory, observe again. Okay, so we repeat this process. Now another things came out by the general theory of relativity is a black hole. The black hole is something the gravity concentrated so much massive. Okay, so what happened is potential, the space is skewed extremely like that. And if you are this area, you have to escape by faster speed, and you can't go beyond light speed. So what's happened is there's some point that even light speed cannot escape anymore, and that's defined the event horizon. So nothing escaped from this area, everything's pulled into the gravity field. Okay, so what's happened is the even light cannot escape. So black hole, this area become totally black. Okay, so from top view, this is the event horizon. It's totally black, and some stars circling around, and this star's behavior can be explained only by the massive existence of massive gravity here. Okay, the many stars circling around black hole, but once it gets into this event horizon, then it's sucked into this black hole, and because of the time dilation by gravity, once you get in, the clock speed start ticking very slowly and almost stop. So inside the black hole is considered as time stops completely. Okay, so time is not something that it's always flow from past to future. Inside the black hole, it doesn't move. It's just clock freeze. Okay, so this kind of things this came out, and also the balance of attractive force and repulsive force of the entire universe. The using gravity that predict existence of heavy material, dark matter, and actually it's like the majority of the weight in the universe is dark matter, which we don't see. The stuff we know, galaxy, stars, planet, is minority. Dark matter probably is going to be 70 to 90% of the weight in the universe, which we haven't seen, and has very extremely low interaction. Low interaction means the even light doesn't interact, so it's dark. It's just like a black hole. The light doesn't interact, it doesn't scatter. That means you cannot see it. Okay, and then the entire universe contract because of the heavy gravity. But what is it keep expanding is there's a repulsive force generated, so there must be dark energy, and this kind of discussion keep going. It's based on the general theory of relativity. So there are several unsolved issues in the physics right now. United theory is general theory of relativity, united gravity and acceleration for the mass. But how about electromagnetic force, actually electric force, okay, and also nuclear force? Those are not united into the single theory, and that was Einstein's dream. He worked on it in his rest of life, and he didn't finish it. It's not completed yet. And there's some discovery, something faster than light speed. It's called entanglement. When you split photon into two photons, they are entangled, and you let it go far away, they are still communicating no matter how fast. And China tested like 100 kilometers apart, still they are communicating. And when you check the spin of this, you can predict the spin here. If spin is up here, then you know spin is down here. And you don't know until you measure. When you measure, find out this guy already behaved according to the result of this, and this speed is faster than light. So this is something the something new. The mechanism is not known, but we know it does exactly the way it's predicted. We can predict. And the probabilistic behavior of quantum, the quantum mechanics, the everything's behave like with a probability, and the behavior of this still not well understood. There's quantum mechanics equations and all kind of theories, but still too many unknown to human. Okay, so those are extremes, small area, and this is like so extreme that the measurement is not easy. The gravitational wave is like a very large scale matter, and that's kind of measured recently. So that scale factor we are approaching to confirm that human has certain scale to handle. But right now, I think the focus is more like a quantum mechanics side, the extremely small areas that things behave differently. And now we can see, even take a picture of the atom. So, this is a new area of physics. Hope you can, continue if you're physics major. You study to the quantum mechanics is the next step. Or of course, you can move to astronomy or cosmology, those area. So those are much different scale from the human. Okay, so that's the end of this college physics, and hope you enjoyed this video. You can find other videos, bunch of exercise program of all the chapters we completed so far. Thank you for listening.